This is an example of a force problem for practice. As a reminder, to solve force problems, read them carefully for variables involving Newton's second law, draw the free body diagram, set up Newton's second law in each coordinate, solve for the unknown, and then check your solution by rereading the problem and looking at the picture. In this example, there are multiple event intervals. First, worker A is pulling a crate along a level force with friction at a constant speed. Second, worker B pulls in the opposite direction to slow the crate to a stop. Read the problem for relevant kinematic as well as force variables. Highlight what is being asked for. Because acceleration is involved, it is best if you solve for it first. Draw the free body diagram for each time interval. Don't forget to declare your coordinate system. For problems involving friction, solve for the normal force first. Use this to calculate the frictional force. Plug this back in for the coordinate with that frictional force. Solve for the unknown and plug in with units. Now let's consider the second time interval. Check what has changed from before. In this case, we have added a force in the negative x direction. The acceleration has become non-zero. Solve for the unknown, and if possible, simplify. In this case, because applied force A is equal to the friction, they cancel out. This makes plugging in easy when we combine with the kinematic solution from before. Reread the problem, checking that you have answered all questions. As always, refer back to your free body diagram to ensure that your solution is sensible.